You already have a fundamental knowledge of mathematics. In this chapter, we'll do a quick review of some of the basics. We'll go over important terminology such as functions, dependent and independent variables, parameters, and constants. This multimedia edition of Teach Yourself Calculus will take you on an interactive journey through the sometimes complex field of calculus. This disc aims to make the journey easy, and in fact, even fun. So, let's get started by trying to recall a few of the key terms and concepts with which you are already familiar. Constants and variables, dependent and independent variables, and functions. Proceed to the next page by clicking on the Next page. So that our review will be more meaningful, we'll use some common examples from everyday life. The formula for the volume of a sphere is V equals 4 over 3 pi r cubed, where V represents the volume and r represents the radius of the sphere. In this formula, V and r vary in different spheres, thus they are called variables. 4, 3, and pi are always the same, therefore they are called constants. Let's calculate the volume of a baseball which has a radius of 2 inches. Using this formula, we find that its volume is 33.5 cubic inches. Now let's replace the baseball with a bowling ball, which has a radius of 5 inches. Again, using this formula, we find that its volume is 523.6 cubic inches. And if we replace the bowling ball with a basketball, which has a radius of 6 inches, we'd find that its volume would be 904.8 cubic inches. To continue, click on the Next page icon. We've seen different types of variables. V, which was the volume of the sphere, and r, which was the radius of the sphere. But the two variables are of a different kind. When we changed the radius, the volume was changed accordingly. R is the independent variable, and V is the dependent variable. In math, it is common to represent the independent variable with the letter X and the dependent variable with the letter Y. Here's a way for you to see this for yourself. In our example, V is dependent on R. Set a radius by clicking anywhere inside the dotted circle and observe how the variable will be changed accordingly. Click on the Next page icon when you're done, or replay to hear this section again. Let's examine the function y equals ax squared plus bx plus c. X is an independent variable, and y is a dependent variable. A, b, and c are constants, and have different values in different functions. A, b, and c in a function are called parameters. In mathematics, it is customary to use x for the independent variable and y for the dependent variable. The constants a, b, and c may have different values, and therefore define different functions. They are called parameters. Click on the Next page icon to continue, or the replay icon to... We know that giving values to a, b, and c will turn the general definition into an actual function. Let's take the values 1, 2, and 3. In this case, we build the function y equals x squared plus 2x plus 3. We can put any value for x in the function and get a resulting y value. We could go on like this indefinitely. Just for good measure, let's try another example. This time the values for a, b, and c will be -2, 1, and 0. Another function will result in y equals -2x squared plus x. Again, we can give any value to x and get a resulting y value. Click on the Next page icon to continue. In order to understand the differences between the parameters, a, b, and c, which change from one function to another, and the variables, x and y, which change within a given function, let's look at the function as though it were a food processor. When we have a parameter in a function, we get different functions for different values of the parameter. Similarly, the food processor can carry out different operations depending on which blade is used. We'll use a simple function to illustrate this concept, but the idea is also valid for functions which have more than one parameter. We can use one of the food processor's blades at a time. Using one blade will produce mashed vegetables, another blade will produce strips, and yet another produces slices. The result depends on both the vegetable and the chosen blade. The vegetable is the independent variable, x, and the blade is the parameter, a. Now let's use one of the parameters. A is equal to 3. Our function will then be f of x is equal to 3x squared. In the first scenario, we assigned the value of 3 to the independent variable, and we got f of x is equal to 3 times 3 squared, which is equal to 27. In the second operation, x is equal to minus 7, and f of x is equal to 147. To continue, click on the next page icon. Now let's see how the independent variables and parameters affect the function's result or its dependent variable. Fill in the parameters and then the x values. Use the Tab key to move from one box to another. For this example, only use values within the range of minus 99 to 99. You can continue changing the values for as long as you wish. Click on the next page icon when you're done. Here is the formal definition for what we have learned. Generally, if two variable quantities, x and y, are so related that, when any value is assigned to x, there is thus determined a corresponding value of y, then y is termed a function of x. Here, x is called the independent variable, or the argument, and y is called the dependent variable, or the function. Click on the next page icon to continue. To express a function, letters such as x and y are commonly used to represent variable quantities. This is a general method used to show a function. We can use g of x instead of f of x, or any other letter such as v of x or m of x. Now it's time to try an example. Click on the pencil icon to go to the exercise screen, or click on the replay icon to repeat this section. We've been dealing with quantities which are functions of a single independent variable, but there are also quantities which are functions of two or more variables. For example, the area of a triangle is a function of both the base and the height. The electric current, I, is a function of the voltage, V, and the resistance, R, of the electric chain. Click on the next page icon to continue. Consider, for example, the function f of x is equal to x squared. We know that for any numeric value assigned to x, a corresponding value of y is determined. We can, however, substitute x by any expression and obtain a corresponding expression for y. In this case, we get the following. In the last example, we constructed a function of two variables, t and u, from the function of f of x is equal to x squared by substituting x with t plus u. Click on the exercise icon to get more experience in working with functions. In this chapter, we have learned about variables, dependent and independent, constants, numbers and parameters, functions, math notation. All functions generate pairs of numbers, since they correspond with a result for any given x value. As you know, pairs of numbers can mark a point on a plane which has an x-axis and a y-axis.